was the question we're solving. Now, having accomplished up to this level of an, you can now simplify further, knowing that sine n minus pi over 2 is equal to minus sine n pi over 2. This is because sine function is an odd function. Sine function is an odd function such that f of x is such as f of minus x is equals to minus f of x. So wherever we see sine n minus pi over 2, we can replace it with minus sine n pi over 2. So we continue an to be equals to minus 1 over 2 into minus sine n pi over 2 divided by pi n over 4 plus 1 over 4 into 2 sine n pi over 2 divided by pi n over 4 minus 2 sine n pi over 2 divided by pi n over 4, and this becomes plus 1 over 2 right here now, plus 1 over 2 into minus sine n pi over 2 divided by pi n over 4. Now, when we look at this equation, we can see that these two terms here, this and this, they are similar. So this turns to 0, and also these two terms are also similar. So this turns to 0. So in essence, we are saying that an is equal to 0. Now we can go back to where we calculated a naught, and so that we can recall that what is a naught? A naught is 0, and we also calculated an to give us 0. So the next thing on our agenda is to evaluate bn, and from the formula we have bn to be 2 over l integral of minus l over 2 plus l over 2 f of x sine 2 pi nx over l dx. Now recall that l is equals to 8. Okay, l is equals to 8. So let's substitute our values for l. So we have that bn is equals to 2 over 8 integral of minus 4 to plus 4 f of x into sine 2 pi nx over 8 dx. So in essence, we're having this will be 1 over 4 integral of minus 4 to 4 f of x sine pi nx over 4 dx. Now let's recall our question that f of x is a range of 3 functions of minus 2, x, and 2, and this ranging from minus 4 less than x less than minus 2, and this is minus 2 less than x less than 2, and the final 2 ranges from 2 to 4. So because of the discontinuous function, we can henceforth split bn into 3 places. That's 1 over 4, from minus 4 to minus 2, f of x sine pi x over 4 dx plus 1 over 4, we integrate again minus 2 to 2 f of x sine pi nx over 4, and finally plus 1 over 4 integral from 2 to 4 f of x sine pi nx over 4 dx. Now the next thing to do is to substitute the term corresponding to the limits. Okay, so we have that bn is equals to 1 over 4 integral of minus 4 to minus 2. When we are considering the limit of minus 4 to minus 2, f of x is minus 2. So we have f of x to be minus 2 multiplied by sine pi nx over 4 dx plus 1 over 4 integral of minus 2 to 2. Now when we are considering the order of minus 2 less than x less than 2, our f of x is x rather. Our f of x is x. So we substitute f of x to be x sine pi nx over 4 dx. And finally, when we are considering the limit of 2 to 4, that means 2 less than x less than 4, the f of x there is 2. So we substitute f of x to be 2. So that's plus 1 over 4 into 2, 4 of 2 sine pi nx over 4 dx. Now bn, when we solve further, this cancels this to remain. We have minus 1 over 2 from integral of minus 4 minus 2 sine, let's bring the n outside, sine n pi x over 4 dx plus 1 over 4 integral from minus 2 to 2 x sine, let's bring the n outside here, n pi x over 4 dx. And we are here, so this 2 will cancel this 4, so we'll be left with 1 over 2 integral of 2 to 4 of sine, bringing the n outside, left with pi x over 4 in the brackets dx. So the next thing to do now is to derive or evaluate the integration process. So evaluating the integration process, we can see that the first term and the third term can be integrated directly. However, we are going to be left with this, so that we will apply uv, and we recall that when we integrate uv, we have uv1 minus u prime v2 plus u prime prime v3, and it continues, where u is equals to x and v is equals to sine n pi x over 4. So our u prime is equals to 1, as we differentiated x, and our u prime prime is equals to 0, that is we differentiating 1. So v1, which is integral of v with dx, which is the integral of sine n pi x over 4 with dx, this is going to give us minus cos n pi x over 4 divided by n over 4. And we can evaluate v2 by integrating v1 with dx, and v1 is minus cos n pi x over 4 divided by pi n over 4. If we're integrating this with dx, we would have minus sine n pi x over 4. Okay, let's rewrite that. Minus sine n pi x over 4 all divided by pi n over 4 whole squared. So the next step now is to integrate, continue with our bn. Okay, so bn now will be minus 1 over 2, and when we integrate sine n pi over 4, okay, we'll have minus cos n pi x over 4 divided by pi n over 4, from minus 4 to minus 2, plus 1 over 4. Now when we integrate uv, we will follow this formula here, and we start with our u is x, our v1 is this minus cos n pi x over 4 divided by pi n over 4 minus u1 u prime, which is 1, multiplied by v2, which is this, as minus sine, okay, minus sine n pi x over 4 divided by pi n square over 4. Now, with this, we give all our limits from minus 2 to 2. And finally, we will be integrating the third term of dn, which we will have it to be plus, okay, plus 1 over 2. And integrating sine n pi over 4, we'll have minus cos n pi x over 4 divided by pi n over 4 from the range of 2 4 2 to 4. Now, a bit much, but we are going to get through this. So bn, reducing the term, okay, this minus can multiply this minus, okay, so that we are left with plus. So we have 1 over 2 into cos n by x over 4 divided by pi n over 4, everything from minus 4 to minus 2, plus 1 over 4 about minus x n by x over 4 divided by pi n over 4, and this minus multiplies this minus, and we'll have a resulting answer of plus sine n of pi x over 4 divided by pi n over 4 squared from levels of minus 2 to 2, plus 1 over 2, or this one turns to minus 1 over 2 because of this minus here, of cos n pi x over 4 divided by pi n over 4 from 2 to 4. So after this is done, the next thing we are going to do is impute the limit, the upper limit minus lower limit. Okay, now let's add upper limit and also lower limit. So bn, upper limit of this and lower limit of this. Let's try something new. Okay, so let's plug in our upper limit and also our lower limit. So bn is 1 over 2. So the upper limit here is minus 2. So we have cos n into minus pi over 2, okay, divided by pi n over 4 minus the lower limit of minus 4. So wherever we see x, we put minus 4. So we have cos n of minus pi, okay, over pi n over 4. Now the next level, next term is this. So we plug in our upper limit and lower limit. So it will be plus 1 over 4. The upper limit in this case is plus 2, and the lower limit is minus 2. So we start with plus 2, that's 2. So wherever we see x, we put 2. So we have minus 2 cos n pi over 2 because x is 2 there. divided by pi n over 4 plus psi n pi over 2 divided by pi n over 4 squared minus, now let's deal with the lower limit. So wherever we see x, we put minus 2. Okay, we are still on the second term. That will give us 2 cos n pi over 2 divided by pi n over 4 plus sine, this will be minus pi over 2 plus sine into sine n into minus pi over 2 divided by pi n over 4 all squared. Now, finally on the last term, we have 1 over 2, and let's put our upper limit of 4 cos n pi divided by pi n over 4 minus lower limit of 2, that's cos n pi over 2 divided by pi n over 4. So, with this done, we can now also reduce the terms bit by bit. Apologies, bit by bit. And then since we know that, okay, we know that cos n minus pi over 2 is the same thing as cos n pi over 2, because cos is an even function and this is equals to 0. And furthermore, cos n pi, okay, cos n pi or cos n minus pi is the same thing as saying cos n pi, which can be plus 1 or minus 1 as the case may be. And sine n minus pi over 2 is the same thing as minus sine n pi over 2, because sine is an odd function. Okay, and these values can range from minus 1 to 0 and to plus 1. So with this done, we can see that cos n minus pi over 2 is 0. Okay, and it is still reflecting here as cos n pi over 2, so this term turns to 0. This term here also turns to 0. Likewise, the term here, which turns to 0. So with that done, we are left with a 1, we are left with 2, with 3, and also the fourth term. So Bn is equals to 1 over 2 multiplied by minus cos n minus pi divided by pi n over 4 after taking this, and thereafter we can deal with this, plus 1 over 4. 1 over 4 came from here, and we have sine n pi over 2 divided by pi n over 4 squared, and this will be minus this term here, minus sine n minus pi over 2 divided by pi n over 4 squared. And finally, this term, which is minus 1 over 2 into cos n pi divided by pi n over 4. Now, let's simplify further and we make the substitution of cos n minus pi to be equals to cos n pi, and we also make the substitution of sine n minus pi over 2 to be equals to sine n pi over 2. This is an even function and this is an odd function. So with respect to that, we evaluate Bn to give us minus 1 over 2 into cos n pi over pi n over 4, okay, because we made the substitution here, plus 1 over 4 into sine n pi over 2 divided by pi n over 4 squared, minus, we will now make the substitution of this, and we have minus into minus sine n pi over 2 divided by pi n over 4 squared. Now we can see that this minus and this minus can multiply together to be plus, so therefore this becomes plus, and we have minus 1 over 2 plus n pi divided by pi n over 4. So with respect to this now, we can bring the sine functions together and also bring the cosine functions together. So we can say that this term is similar to this term. So we can say Bn is minus 1 over 2 cos n pi n over 4. And take this also, minus 1 over 2 cos n pi divided by pi n over 4 is like collecting like terms. Okay. And then we have it plus this term 1 over 4 into sine n pi over 2 divided by pi n over 4 squared plus sine n pi over 2 divided by pi n over 4 all squared. Now it's getting more simplified after we collected like terms. So since these two are similar, we have it to give us minus 1 multiplied by cos n pi divided by pi n over 4. And this will give us plus 1 over 4, and altogether it will give us 2 sine n pi over 2 divided by pi n over 4 whole squared. Okay. So since 2 can cancel out 4 to give us 2, we have that Bn is equals to minus 1, or simply minus cos n pi divided by pi n over 4 plus 1 over 2 into sine n pi over 2 divided by pi n over 4 squared. Now with this, we will be able to evaluate B1, B2, B3, and as well as B4. So after, it might take a minute to plug in your values of B1, B2, B3, and B4. That is when n is equals to 1, n is equals to 2, n is equals to 3, and n is equals to 4. And pause the video and then you confirm. And B1 is equals to 4 over pi plus 8 over pi squared. B2 will give us minus 2 over pi. B3 will give us 4 over 3 pi minus 8 divided by 3 squared pi squared. And B4 is going to give us minus 1 over pi. So after this is done, we have our values of B1, B2, B3, and B4. And we also record that A naught is equals to 0 and AN is also equals to 0. Okay, and then our formula for f of x, okay, that we have from the beginning of Fourier series over any range is that f of x is equals to a naught over 2 plus summation of n is equals to 1 to infinity of an cos 2 pi nx over L plus bn sine 2 pi nx over L. Now, with this done, we know that a naught is 0, so this term is 0, and an is 0, definitely this term is 0. So our f of x is equals to summation of n is equals to 1 to infinity of bn sine 2 pi nx over L. Now recall that our L is equals to 8. Now if L is equals to 8, then, apologies again, then f of x is equal to summation of n is equals to 1 to infinity of bn sine pi nx over 4. Now, so we begin to slot in our values of b1, b2, b3. So using this further, we have that f of x is equals to b1. So that means we are taking n is equals to 1 sine pi x over 4 because n is 1 plus b2 multiplied by sine pi x over 2 because n is equals to 2 plus b3 multiplied by sine when n is 3, we have pi 3x or 3 pi x over 4 plus when n is 4, that's b4, and we have sine pi. When n is 4, we are left with pi x plus dot dot dot. So let's substitute our values for b1. This is b1, 4 over pi plus 8 over pi squared. So our Fourier series is 4 over pi plus 8 over pi squared multiplied by sine pi x over 4 plus b2. Now our b2 is minus 2 over pi. So this changes to minus 2 over pi sine pi x over 2 plus b3. Our b3 is the entire of this, which is 4 over 3 pi minus 8 over 3 squared pi squared multiplied by sine 3 pi x over 4, and finally b4. Our b4 is minus 1 over pi, that was 1 plus 1 over pi sine pi x. So in conclusion, the Fourier series of a function over any range is given by the formula which we have from the beginning of the video. So let's take a step back and then we solve. Let's see the question. So this is the formula for Fourier series over any range. So with this formula, we'll be able to simplify any questions that come our way. Now, next video, we'll be looking at Fourier series for f of x is equals to 2x minus 1 in a half range sine series.